Good morning everyone. Today we'll conduct the experiment on Venturimeter virtually. So Venturimeter is a flow measurement device which is based on the principle of Bernoulli's equation. Inside the pipe, pressure difference is created by reducing the cross-sectional area of the flow passage. So this difference in pressure is measured with the help of manometer, and it will help in determining the rate of fluid flow or other discharge from the pipeline. Venturimeter has a cylindrical entrance section, converging conical inlet, and a cylindrical throat and a diverging recovery cone. So as you can see here, this is a Venturimeter, which is a eccentric type is given in the first image and rectangular type is given in the second image. So there are many components of Venturimeter like cylindrical entrance section, converging conical section, throat section and diverging section. There are many types of Venturimeters: a standard long form or a classic Venturi tube, a modified short form where the outlet cone is shortened, an eccentric form to handle mixed phases or to minimize buildup of heavy materials, a rectangular form used in duct work. So now we'll see the procedure to conduct the experiment. So this is the procedure to conduct the Venturimeter experiment, where the objective is to find the coefficient of discharge of the given Venturimeter. So we need Venturimeter setup, differential manometer, collecting tank, piezometer, stopwatch and measuring scale. In step 1, a pipe of required diameter is selected, others are kept in the closed position. So here we have 50 mm, 40 mm and 20 mm diameter of pipes, and we are going to select the pipe of required diameter. Then we are going to proceed the experiment. So after that, the main inlet valve is opened to allow the water to flow through the selected diameter pipe. Then open the pipe valve and change the knot of manometer from isolate position to air vent position to remove the air inside the pipe. Then in the next step, we are going to allow the main inlet valve to open in order to allow the water to flow through the selected diameter pipe. And after opening the pipe valve, change the knot of the manometer from isolate position to air vent position in order to remove the air inside the pipe. Next, the knob is then kept in the read position, and we are going to note down the manometer reading, like left ring manometer reading and right ring manometer reading. Then we are going to find the difference of both. After this, the water is now allowed to flow through the selected Venturimeter, and this flow is made constant. At this flow, the difference in pressure between the inlet and the throat is measured. The exit valve of the collecting tank is then closed, and the time taken for tank water to rise by 5 cm is noted. After that, we are going to calculate Q theoretical and Q actual values, and then the coefficient of discharge values. So now we'll see the procedure and how to perform the experiment. So this is the Venturimeter setup, where the different diameter pipes are connected and a valve is given here, and there is a collecting tank also. So now we need to select the pipe of required diameter. Suppose I select 20 mm diameter. So the length of the pipe will be 3 meters. So now I'm going to open the main inlet valve, and I'm going to allow the water to flow through the diameter, which is flow through the 20 centimeter diameter pipe which I am selected. And by opening this pipe valve, we need to change the knot of the manometer from isolate position to air vent position in order to remove the air which is present inside the pipe. So now I have opened this particular valve. So the water is flowing inside the pipe now. So I am going to open the pipe valve. So after that, See, this is an isolated position. I'm going to make it as air vent position. So this is air vent position. So if this is done, the water, the air, whatever is present in the pipe, that will be removed out. So next, I'm making it in the read position. So now you can read the manometer here. So the the left limb reading was 53 and right limb reading was 27. So 53 minus 27 will have 26. So 12.6 we need to multiply for this difference. It is 327.6. The result will be 327.5999 centimeters. So now water is allowed to flow through the selected venturimeter and this flow is made constant. At this flow rate, the difference in pressure between inlet and throat is measured. After that, the exit valve of the collecting tank is closed and we are going to note down the time taken to collect that water in the collecting tank for about 5 centimeter is noted down. So here the time taken was 23 seconds. After this, we are going to find Q actual value. It was found to be 1467.39 and Q theoretical is found using the formula A1 into A2 into root of 2GH into root of A1 square minus A2 square. So Q theoretical was found to be 1672.386. So therefore, coefficient of discharge CD was found to be 0.88. So this is trial 1. So the same way we are going to do trial 2. I am going to open the main inlet valve. Then water is allowed to flow here. And I'm opening this valve. And also here I'm going to open the knot and make it from isolated position to air vent position. Next I'm going to make it a read position. So now manometer will be reading. So the reading was 46.4 in the left limb minus 36 in the right limb. It is 10.4 into 12.6. We get around 131.04. So next we are allowing the water to flow in the venturimeter. Then I'm closing the exit valve in the collecting tank and the time taken to collect for about 5 centimeter rise in the collecting tank was noted down and it was found to be 34 seconds. So now Q actual is calculated. And it was found to be 992 and Q theoretical was found to be 1057.7098. So 992.65 divided by 1057.0798 will give us the coefficient of discharge, which was found to be 0.94. So next, again the same thing is done in the trial 3. I'm going to open the valve and the water is made to flow here. I'm going to open again this valve and then the position of the manometer knot is changed from isolated to air vent position. Then I'm going to read the manometer. So the reading was found to be 42 minus 40, which is 2 centimeter. 2 into 12.6 is 25.2. So which is a correct one, and we are allowing the water to flow in the venturimeter. So now I'm going to stop the exit valve. I'm closing the exit valve and then I'm going to record the time taken to collect 5 centimeter of water in the collecting tank. It was found to be 87 seconds. So now I'm going to calculate Q actual, which was found to be 387.97 and Q theoretical was 463.8364. So now I'm going to calculate coefficient of discharge as 387.93 divided by 463.8364, which is equals to 0.84. So here ends the trial 3, and again the trial 4 is continued for the selected diameter of the pipe. So if I select here, again the same thing we'll be doing here also. We are going to make it from the isolate position to air vent position. After that, the readings of the manometer is taken, and we are calculating head loss 65.52 centimeters. Then we are allowing the water to flow in the Venturimeter. Then I'm closing the exit valve and recording the time taken to water to fill 5 centimeter height. It was found to be 49 seconds. Then I'm going to take the value of Q actual, which was 688.78, and Q theoretical was 747.9137. Coefficient of discharge was found to be 0.92. So here ends the experiment with 4 trials, and next we are going to take the characteristics curves, that is Q actual versus H. So this is the curve which we are getting here. So after plotting the curve, we are going to find Q actual and Q theoretical values are not found here. We are going to find the slope of the graph, and then we are going to calculate the coefficient of discharge. So here ends the experiment.